Every time you step outside, you're literally looking at millions of years of problem solving. Welcome to this explainer. Today, we're going to decode exactly how living things biologically adapt to survive in their environments. Now, at first glance, the natural world might just seem like a random mix of animals living in different places. But when we actually look closer, we see incredible, highly specific design. Every single living thing is a masterclass in survival, perfectly tuned to its exact habitat. We're going to unpack the science of how that happens and why understanding it completely changes the way you look at nature.
Here is our roadmap. We're going to define what an adaptation actually is, break down the structural, physiological, and behavioral categories, and then look at some really complex case studies.
All right, section 1. What is an adaptation? Let's get our biological baseline sorted.
At its core, an adaptation is precisely defined as a change in a living thing that helps it survive in its specific environment. Now, this isn't about an animal just waking up one day and deciding to change, right? It's about gradual biological and evolutionary shifts over time that give an organism a distinct advantage. If an environment is insanely hot or freezing cold or absolutely packed with predators, the living things that survive there are the ones that have undergone these necessary biological changes. And this perfectly illustrates the main difference we'll be exploring today. Think about the stark contrast between possessing a physical biological tool, like a hawk having these long, razor-sharp talons, versus performing a deliberate survival action, like an opossum literally playing dead to avoid getting eaten. One is a physical thing the animal has, the other is an action the animal does. Keeping that sharp distinction in mind is absolutely crucial as we dive into the specific categories. Moving right along to section 2, structural adaptations. This is all about physical features for survival.
A structural adaptation is strictly categorized as a physical feature that directly aids in an organism's survival. A perfect example is a bird's beak. When you look at an animal, these are the traits you can actually see with your own eyes. They are built right into the physical anatomy of the living thing, designed by nature to solve a very specific environmental problem.
Take a blazing hot desert, for example. To survive there, the camel actually developed 2 rows of incredibly thick eyelashes. That structural feature acts like a perfect shield protecting its eyes from blowing sand. Plus, it stores fat in its hump to provide energy for when food is virtually impossible to find. Now, let's look at the complete opposite extreme, the open sky. The peregrine falcon evolved the structural capacity for crazy fast flight and excellent eyesight. That physical hardware allows it to accurately spot and track prey from extremely far away. We see this everywhere. Look at the red-eyed tree frog. It uses a green body to brilliantly camouflage among rainforest leaves. But structurally, it also possesses these brightly colored eyes, feet, and sides specifically designed to flash and totally confuse predators. Meanwhile, the chameleon relies on a wildly different structural feature. It has the physical ability to actually change color, and it's got this long, super powerful tongue that shoots out like a rocket to catch its prey. Remember, these aren't choices the animals make. These are physical, structural features they possess. But what happens when the mechanism for survival operates entirely inside the animal's body? Well, that brings us to section 3, physiological adaptations.
We classify this as a physiological adaptation. This is formally defined as an internal body process that helps a living thing survive. The quintessential example here is a snake producing venom. You can't usually see a physiological adaptation just by looking at the outside of the animal, because it's a hidden chemical or biological process working behind the scenes to make sure that organism can get food or defend itself. Okay, our final subcategory shifts totally away from what an animal possesses or processes internally. Welcome to Section 4, Behavioral Adaptations, which is all about changes in how living things act. A behavioral adaptation is officially defined as a change in how a living thing acts to survive. A classic example would be birds migrating for the winter. This is all about action, right? It's the strategies, the specific movements, and the habits that a species has developed over countless generations to outsmart predators, survive brutal seasons, or successfully reproduce. Now, what's really fun is testing out how clearly we can map these traits. Let's look at a breakdown. Think about actions. Beavers building dams to create ponds, male elk bugling to attract mates, spiders spinning webs, and opossums playing dead so predators leave them alone. Those are all checked off strictly under the behavioral column. They are actions. Conversely, the physical webbed feet that help penguins swim, and the long, sharp talons hawks use to grab prey, those check the box exclusively under structural. By sorting them out like this, the biological baseline makes total sense. All right, let's bring all these formal definitions together for Section 5, Complex Adaptation Case Studies. We're going to see how animals layer these traits for ultimate survival. Let's examine our first masterclass case study, the giraffe. To absolutely dominate the savanna habitat, the giraffe doesn't just rely on one trick. It combines several massive structural traits. First off, it features an incredibly long neck, giving it exclusive access to reach tall trees for food that other grazing animals simply cannot get to. Second, it has a spotted coat acting as perfect camouflage among the trees and grass. And third, it utilizes massive, long legs to cover vast distances efficiently in search of food and water across that sprawling, dry landscape. Every inch of the giraffe is a structural adaptation tuned specifically for the savanna. Meanwhile, in a completely different world, the tropical rainforests and wetlands, we find the anaconda. Its adaptations are perfectly suited to a swampy, aquatic life. The anaconda layers its camouflage, specifically its green and brown skin designed for blending right into the muck, with incredibly powerful muscles meant for constricting prey. But perhaps the most brilliant structural layout? Its nostrils and eyes are positioned right on the very top of its head. It's literally like a built-in snorkel. This allows the anaconda to breathe and see clearly while keeping the rest of its massive body perfectly submerged and hidden in the water. So, we've seen how structural features, physiological body processes, and behavioral actions all perfectly align to make an animal a master of its domain. Which leaves us with a critical biological question to ponder. As our global environments rapidly shift, what happens to living things when environmental change outpaces their ability to biologically adapt?
It's a question that challenges the very foundation of survival by design. Thank you for joining me for this explainer. I really hope you walk away with a totally new view of the natural world.